You think you're just having a drink. But the moment that whiskey touches your lips, your body declares a silent emergency. And what happens next, deep inside your cells, is one of the most dramatic journeys in all of human biology. Look at it. That amber liquid sitting in the glass, catching light like liquid gold. It looks harmless. But inside that simple fluid is a chemical universe of staggering complexity. Jack Daniels is 40% ethanol by volume. In every shot, you are consuming 17.5 milliliters of pure ethyl alcohol. Formula CHCH-PuNOH. 2 carbons, 6 hydrogens, 1 oxygen. Deceptively small. Surrounding that ethanol are hundreds of compounds called congeners. The chemical fingerprints of years spent aging in charred American white oak barrels. Vanillin gives the warm sweetness. Guaiacol gives the smoky depth. Tannins deliver the dry finish. Acetaldehyde sharpens the aroma that hits your nose first. This is not just a drink. It is a chemical symphony composed over years, inside a charred wooden chamber, waiting for this exact moment. The whiskey hits your tongue and your body responds immediately. Thousands of taste receptor cells inside your tongue's papillae fire simultaneously. Bitter receptors responding to the phenols, sweet receptors activating at the vanillin compounds, umami receptors engaging the amino acid-like congeners. The signals race along cranial nerves V8 and IS to your brainstem in milliseconds. Your 3 pairs of salivary glands ignite. Saliva floods the oral cavity carrying salivary amylase, which immediately begins attacking residual carbohydrate compounds in the whiskey. But something more significant is already happening. Ethanol molecules are so small and chemically amphiphilic, comfortable in both water and fat, that they begin dissolving directly through your oral mucosal lining before you even swallow. Right now, tiny amounts of alcohol entering your bloodstream directly through the tissue of your inner cheeks and the underside of your tongue. This is why experienced drinkers feel the first subtle effects almost immediately after the sip, before digestion has even begun. The bolus forms, the epiglottis seals the airway shut, and the whiskey begins its descent. 25 centimeters of esophagus separates your throat from your stomach. The upper esophageal sphincter opens. Peristalsis, coordinated muscular waves squeezing behind the bolus, propels the whiskey downward at approximately 4 centimeters per second. The esophageal lining, a stratified squamous epithelium built for mechanical wear, begins experiencing ethanol's corrosive chemistry. Tight junction proteins between adjacent cells start loosening. The protective mucus layer thins. Inflammatory signals stir in the tissue below. This is why chronic drinkers develop esophagitis. The esophagus was not designed for repeated alcohol exposure. It tolerates it, but it never forgets. At the base of the esophagus, the lower esophageal sphincter relaxes and the whiskey enters the stomach. The stomach is ready. Gastran floods the bloodstream. Parietal cells deep in the gastric glands activate their proton pumps, generating hydrochloric acid at a pH of 1.5, strong enough to dissolve metal. 3 layers of smooth muscle begin churning the whiskey with acid and pepsin in violent coordinated waves. A process so forceful, it repeatedly slams the contents against the closed pyloric sphincter and back, ensuring complete mixing. Meanwhile, ethanol systematically dismantles the stomach's own defenses. It dissolves through the protective mucus barrier. It loosens the tight junctions of the gastric epithelium. It forces gastric acid backward through the epithelial lining into the tissue beneath, a process called back diffusion, triggering inflammation, mast cell activation, and early mucosal erosion. The whiskey has been transformed into an acidic, churning fluid called chyme. The pyloric sphincter begins releasing it in controlled pulses into the small intestine. The real disassembly is about to begin. The duodenum receives the chyme like a precision chemical processing plant. Alkaline secretions from Brunner's glands immediately neutralize the acid, secretin and cholecystokinin. Hormones released by the duodenal lining race through the bloodstream to the pancreas and gallbladder. The pancreas responds with its full enzymatic arsenal. Lipase to dismantle fats, trypsin and chymotrypsin to cleave proteins, amylase to finish the carbohydrates. The gallbladder contracts, squeezing concentrated bile through the biliary tree and into the duodenum. Bile salts immediately emulsifying the fat-soluble congeners into tiny micelles that enzymes can access. In the jejunum, intestinal villi, finger-like projections covered with millions of even finer microvilli create an absorptive surface area equivalent to a tennis court. Brush border enzymes complete the final molecular dismantling. Jack Daniels' complex chemical mixture has been reduced to its fundamental units: free glucose, amino acids, fatty acid chains, minerals, water, and ethanol, which needs no digestion whatsoever. Absorption begins across 250 square meters of living intestinal surface. Glucose crosses through SGLT1 transporters. Amino acids pass through dozens of specific protein gateways. Fatty acids are repackaged inside enterocytes into large lipid spheres called chylomicrons and released into the lymphatic lacteal vessels of each villus. Bypassing the bloodstream entirely, entering the lymphatic system instead, ethanol crosses everywhere, through every membrane, through every cell, through the spaces between cells. It requires no transporter, no energy, no invitation. It simply moves down its concentration gradient, and nothing in the body's architecture can stop it. The portal vein collects the nutrient-rich blood from the intestinal capillaries and carries it directly to one destination: the liver. The liver is your body's primary chemical defense, positioned like a sentinel between the gut and the rest of your body. Portal blood flows through hepatic sinusoids, wide specialized capillaries whose fenestrated walls allow direct contact between the blood plasma and the liver's working cells, the hepatocytes. Kupffer cells patrol these channels, sampling everything arriving from the gut. When alcohol-derived bacterial endotoxins arrive, leaking through the gut wall that ethanol has made permeable, Kupffer cells activate TNF-alpha, IL-1 beta, IL-6. Inflammatory signals radiate outward. The hepatocytes begin metabolizing the ethanol through alcohol dehydrogenase ADH, a zinc-containing enzyme that oxidizes ethanol into acetaldehyde. This is where the real danger lies. Acetaldehyde is toxic. It attacks proteins and DNA. It drives inflammation. The liver's aldehyde dehydrogenase quickly converts it to acetate, but with heavy consumption, this system saturates. The backup system engages CYP2E1 in the smooth endoplasmic reticulum. It processes ethanol efficiently but generates reactive oxygen species as byproducts, superoxide radicals, hydroxyl radicals. These attack cell membranes, proteins, and DNA from within. Fat begins accumulating in hepatocytes as fatty acid oxidation shuts down. The liver is fighting, but it is sustaining damage with every battle. Some ethanol has escaped. It is in the bloodstream. It is heading for the brain. The blood-brain barrier stops almost everything. Pathogens, large molecules, most drugs. Ethanol walks straight through it. Within 30 to 90 seconds of your first sip, ethanol is already in your brain parenchyma, dissolved directly through the endothelial cell membranes of cerebral capillaries without asking permission. It potentiates GABAA receptors, the brain's primary inhibitory ion channels. Chloride floods into neurons. The brain's excitatory activity drops. Anxiety softens. Inhibitions loosen. The world feels warmer, easier. It blocks NMDA glutamate receptors, the brain's primary excitatory channels, and the molecular machinery of memory formation. Calcium cannot enter. Long-term potentiation cannot occur. New memories cannot form. The record button has been switched off. It floods the nucleus accumbens with dopamine. By silencing the interneurons that normally hold the dopamine system in check, ethanol unleashes a surge of reward neurotransmitter: pleasure, warmth, the desire to drink again. And in the cerebellum, the brain's coordination center, Purkinje's cells begin misfiring. Their extraordinarily complex calcium-dependent rhythms are disrupted. Coordination signals to the motor cortex become irregular. Your balance shifts. Your reaction time slows. You feel wonderful. Your brain is being chemically compromised. Both of these things are simultaneously true. The ethanol reaches the heart through the coronary arteries. Peripheral vasodilation spreads warmth across your skin. Heart rate rises slightly as the autonomic nervous system compensates for the blood pressure drop. Inside cardiomyocytes, calcium handling is disrupted. The sarcoplasmic reticulum begins leaking calcium at irregular intervals, introducing subtle timing errors into the cardiac rhythm. The heart keeps beating. But with chronic exposure, the risk of atrial fibrillation climbs, a phenomenon so well documented in heavy drinkers it has its own name: holiday heart syndrome. In skeletal muscle, GLUT4 glucose transporters fail to fully translocate to the cell membrane. Glucose uptake falls. The mTOR protein synthesis pathway, the molecular engine of muscle repair and growth, is suppressed. Whatever training you did today is being quietly undermined. In bone, vitamin D activation is disrupted. Osteoblast activity slows. Calcium absorption from the gut decreases. The skeleton is silently losing density. The gut microbiome is in crisis. Beneficial bacteria, Lactobacillus, Bifidobacterium, are dying. Pathogenic species are proliferating in the ecological vacuum. The intestinal barrier is loosening further.
Bacterial toxins are leaking into systemic circulation, maintaining the inflammatory state the Kupffer cells initiated hours ago. The body is managing. It always manages, but it is keeping score. The liver clears ethanol at 1 standard drink per hour. That rate is fixed. Nothing accelerates it. The kidneys have been filtering ethanol-containing blood through their glomeruli, the microscopic filtration units of the renal cortex. Since absorption began, ethanol passes freely into the tubular filtrate but largely reabsorbs back. Its metabolites, ethyl glucuronide at G and ethyl sulfate at S, cannot reabsorb. They concentrate in the collecting ducts and accumulate in the urine. Eg remains detectable for 24 to 80 hours after drinking, long after the alcohol itself has vanished from the blood. It is the metabolic fingerprint you cannot erase. The lungs are publishing your blood alcohol level to the world with every exhale breath. Ethanol evaporating from the alveolar blood into the expired air at a concentration proportional to what is in your blood. The basis of every breathalyzer ever used. The large intestine compacts the remaining waste. The kidneys send urine to the bladder. The bladder empties. The body closes its accounts. One drink, one sip. From the moment it touched your lips to the last trace of ethyl glucuronide leaving your kidneys tomorrow morning. That single shot of Jack Daniels triggered simultaneous biological responses across your oral mucosa, esophagus, stomach, pancreas, gallbladder, small intestine, lymphatic system, liver, heart, skeletal muscle, bone, gut microbiome, blood-brain barrier, GABergic synapses, dopamine reward, circuit, cerebellum, stress hormone axis, kidneys and lungs, every organ, every system, all at once. The human body is not a passive vessel for what you pour into it. It is an active, remembering, fighting biological machine of incomprehensible complexity, absorbing insults, repairing damage, maintaining balance, keeping you alive, quietly, without complaint, every single time. The only question that actually matters is how long you intend to keep asking it to. Like and share this video to your friend and subscribe this channel. Thank you. Take care, my friend.